This door opens because an independent Unreal Engine 5.5 C++ actor calls an interaction interface. The caller never invokes a door-specific open function. It verifies the interface, reads the action name open door, executes interact, and the door moves from closed through 47% to a full 90-degree open state. In this lesson, we will declare UInterface and IInterface types, add Blueprint native events, implement the functions in C++, dispatch through execute interact, animate around a real hinge pivot, and verify the interface path with real frames, logs, and automation. An Unreal interface has two related types. UInteractable is the reflected UObject wrapper generated by UInterface. IInteractable is the C++ contract that declares the functions implementers provide. This contract defines interact with an interactor actor and get interaction name returning text. It describes capability without requiring shared storage or an inheritance tree. A door, chest, pickup, terminal, or non-player character can expose the same interaction contract while keeping completely different internal state. The two interface functions use BlueprintNativeEvent and BlueprintCallable. The door implements interact_implementation and get interaction name _implementation in C++. Unreal generates the public dispatch layer. BlueprintNativeEvent is useful when C++ should provide reliable default behavior while compatible Blueprint classes retain the option to override it. Callers still use one interface entry point, regardless of whether the active implementation comes from C++ or Blueprint. Before calling, the driver checks getClassImplementsInterface with UInteractable static class. It then reads the interaction label through execute getInteractionName and dispatches the action through IInteractable execute interact. Using the generated execute function matters because it correctly routes both native and Blueprint implementations. A direct cast to IInteractable is not sufficient for every Blueprint-only implementation. The interface check and execute path are the reflection-safe Unreal pattern. The door's interact implementation rejects repeated calls while it is opening or already open. For the first valid call, it sets the opening flag, resets elapsed time, changes the status text, and logs the real interactor actor. The caller does not know the open duration, target angle, material color, pivot hierarchy, or completion state. Those remain private implementation details. This is the practical value of the interface, stable intent at the boundary and class-specific behavior behind it. The door panel is offset from a scene component pivot placed on the left hinge. Tick runs only while opening. Elapsed time divided by the 1.5 second duration produces a 0 to 1 alpha. Smooth step eases that alpha, and lerp converts it into a 0 to 90 degree yaw. The pure calculation is verified at 0, halfway, completion, and after completion. At 0.75 seconds, it returns 45 degrees, and values beyond the duration remain clamped at 90. These are 3 real frames from the saved interface door map. The closed state shows the blue panel filling the frame. After execute interact, the panel turns amber, rotates around the hinge, and reports opening 47%. At completion, the doorway is clear, the panel is green at 90 degrees, and the label reads door open. The orange collar remains separate from the door. The visible transition comes from the real interface dispatch and compiled door implementation. The runtime log proves the door implements the interface, names interaction driver actor 0 as the interactor, records action open door through the generated execute path, reaches 90 degrees, and exits with door open true. Unreal Automation separately verifies interface implementation, default duration and angle, the initial closed state, and exact angles at 0, halfway, completion, and after completion. The test passed with 1 success and 0 failures. Contract, dispatch, animation, visual result, and logs all agree. The reusable pattern is 4 steps. Check that the target implements the reflected interface. Execute the generated interface function. Let each class implement the response. Keep state and presentation inside the implementer. Interfaces are strongest when unrelated actors share one capability, but not one data model. Use them for interaction, damage receivers, save targets, highlightable objects, inventory providers, or mission participants. Avoid putting shared mutable state inside the interface itself.